So if you want to write these notes down on page 323, there's an empty page there, or you can write it on a separate piece of paper. We've looked at what happens. We've sort of had a bunch of special functions. The very first special function that we looked at is what happens if we put f of x inside of a square root. We did that in chapter 2. Now we've looked at what happens if you put any function underneath a graph, underneath, like on a reciprocal. And we just finished doing what does that do to your graph. The last one we're looking at is what happens if we take any function and put it inside of absolute values. What would that do? Well, what does an absolute value do to a y value? Yeah, like if it just changes your y value to positive, right? Like if you had absolute value of -3, it would be 3. If you had absolute value of 7, it's already positive, so it stays at 7. So when we're graphing the absolute value of f of x, the entire graph is going to be above the x-axis. So our steps are going to be similar to what we did with our reciprocal graph. We are going to graph our function inside first. So if you had f of x be 2x plus 3, that would be what would be inside your absolute values. And so if I graph 2x plus 3 first, I would have 3 as my y-intercept, a slope of 2 down 2 over 1, down 2 over 1. And what you're also going to do is on your original graph, draw or label any x-intercepts. So we only have one x-intercept here. What would that x-intercept be? -1.5 or -3 over 2, comma 0. Good. Our x-intercepts are going to be important because when we graph the absolute value, so here is 2x plus 3, and over here I'm going to graph the absolute value of 2x plus 3. All that's going to happen is your y values are all going to be positive. So wherever our graph had positive y values to begin with, which I'm going to highlight here in yellow, can you see that all the y values in that yellow section are already positive? If you do the absolute value of them, nothing's going to change. So that's why it was important for us to find our x-intercept because this part of our graph is not going to change. But everything on this side, which I'm going to highlight in blue, this section in blue, that's where our y values are negative. For example, the one point I have labeled there, I could label it as this point right there, -2, comma -1. Now, if I did the absolute value of that y value, that means on my new graph, I'm going to have -2, comma +1. And this whole section is going to have the same effect as flipping it over the x-axis. So as sort of a shortcut, what we're going to do is we're going to graph our original function, find all of our x-intercepts because that's going to be key points that stay the same, And then anything that's below the x-axis is going to get reflected over the x-axis and get flipped up. Because in a sense, we're multiplying all those values by a -1. And when you multiply your y values by a -1, that's a reflection over the x-axis. Now, we get an absolute value graph. We could have done this same question using our techniques from Chapter 3. Because one of our parent graphs in Chapter 3 in transformations was our absolute value of x. And so this just has some values inside. Whenever things happen inside the function, that affects the x values, it affects it horizontally. So what would that 2 have done as far as talking about transformations? Would have made it a horizontal compression by a half, right? Remember that if it's inside the function, even though it's a 2, you would multiply your x values by a half. And then what would the 3 do? Right. We want to say it moves it 3 to the left. But did it move it 3 to the left? Is our graph wrong here? Or why doesn't it move it 3 to the left? Because that's what a +3 normally does, right? Moves it 3 to the left. Close. Whoa. Absolute value bar got bent. It's too hot out. Okay. We have a horizontal stretch and a horizontal translation. What do you have to do when you have a horizontal stretch and a horizontal translation? You have to factor first. So if you were doing this with transformations, this would be a hard one because most likely you would forget to do the factoring and get so excited about moving it 3 to the left that you would do that. Can you see that this one got narrower by a half, but only moved 1.5 because when I factor out that 2, I get 1.5 or 3/2. So this one could have been done using our old technique, but I actually think our new technique is easier. It's easy to graph the inside function and then flip it up. So in this sense, using our new technique actually makes our life a little bit easier. We didn't have to use transformations. The other nice thing about our new technique is we can now graph or absolute values of all sorts of functions. So now here we have a cubic function that's been completely factored. If you weren't given the graph, you would have known because it's factored that you have an x-intercept at 0, an x-intercept at -3, and an x-intercept at 2. You would have also known, and I'll label those, -3, x equals 0, and x equals 2. You would have also known that since this is a positive x cubed graph from our very first chapter, how do we graph x cubed graphs? Well, they act like lines, so the end behavior will act like a line with a positive slope. We just don't know what would happen in between here. So it's going to start down here, which it does, go through our x-intercepts. It doesn't bounce, it doesn't bend, because the multiplicity of each of those is 1. Boy, there's a lot of good review in this unit. And this is what your graph would look like. Now, if we highlight things again, last time we highlighted, can you see that this section and this section are positive? All of our y values are positive in those sections, but this section and this section, our y values are negative. So wherever we have those negative y values, the absolute value is going to flip them up. And so our final graph will look like this. This bottom blue part would get flipped up. There's going to be a sharp point here. This is going to stay exactly the same. This part gets flipped up, and this stays the same. Whoa, looks like a W. And that's all we would need to do. I'm going to add one more example. Sometimes with absolute value graph questions, you get things that look like this. So I'm going to say, we're going to take y equals the absolute value of the square root of x minus 2 minus 3. So what's different here is I don't just have an absolute value. I have the absolute value, but then at the end, I also have a minus 3. So what we're going to do is we're going to graph this first, and whatever we get as our graph, what will this minus 3 do if that comes after? It's going to move it down 3 units. So we're actually going to have 3 graphs, because how do we graph the green circle first? We graphed the inside first, and then we did the absolute value. So the very first thing that I'm going to graph is the inside of the absolute value, which is y equals the square root of x minus 2. If you graph that using transformations, what does that look like? Take our square root graph and move it down 2. Okay? So if I take my square root graph and move it down 2, instead of 0, 0, can you see that you're going to have 0, negative 2? Instead of 1, 1, you're going to have 1, negative 1. And instead of 4, 2, now you're going to have 4, 0. And here's your square root graph, and that's its shape. Notice that on our square root graph, whoa, wrong color. This part is positive, which we've always colored in yellow, and this part is negative, which we've been coloring in blue. So now, if this is our step 1 as far as graphs go, for step 2, I'm now going to graph. I'll do this one in black. What would happen if I did the absolute value of the square root of x minus 2? What the absolute value does is it just takes the parts that are negative and flips them up. So in other words, we're still going to have 1, 2, 3, 4, this point 4, 0. Instead of having 1 and everything after this stays the same, instead of having 1, negative 1, we're going to have 1, positive 1. Instead of 0, negative 2, we're going to have 0, negative 2, and that would flip this part up. So our graph is looking pretty weird right now. And now finally, the very last thing we have to do is move everything down 3. So instead of 0, 2, if I move that point down 3, I'm going to have 0, negative 1. Instead of 1, 1, I'm going to have 1, negative 2. And for 0, is now going to be 4, negative 3. The shape of the graph is going to stay the same as it was before, like that. Now the reason I wanted to show you this is sometimes students get the feeling that whenever they see an absolute value bar in the original equation, that everything has to be positive. Well, it's true that everything in the green is going to be positive or greater than or equal to 0. But as soon as I subtract 3 from that, can you see that there's a possibility that some of it could be negative? And so, sure enough, in our black graph here, everything was positive. But then when I subtracted 3 at the end, I did have some parts that were negative. So I've seen final exams where sometimes students have gone, oh, I'm going to just keep it, and then bend it up. Like, I can't go into the negative. And just smush it on the x-axis and guess. But it does, because we're subtracting 3, it does go below. And it's because this minus 3, that minus 3 there, is after the absolute value. So I want you to see that, to think about that, so that you're aware that if that happens on an exam or on your test, you know how that works. Another thing that I want to point out that sometimes causes people to make a mistake is when looking inside the absolute values here, you get used to saying if something's inside a function, it moves it left or right. So I have a lot of students sometimes think that this should move this 2 to the right. But if we're graphing the inside first, when we look at that inside function, that minus 2 isn't inside the square root. That's why it's moving that square root down 2, not 2 to the right. And then after that, when we do the absolute value, the only thing the absolute value does is take whatever's negative, that part that's highlighted in blue, and reflect it over the x-axis and make it positive. Okay. And with that, we are done all of our notes.